Hello everyone. So today we will have a quick look at the to and fro motion. To and fro motion. What is to and fro motion? To and fro motion is a kind of motion in which two objects are moving from the opposite direction of a track, of a straight track, right? Straight track. Okay. So let's make a straight track. Let's make a straight track. Okay. This is a straight track, right? And there will be two terminals here. So A and B will start from M and N terminals with a speed of 300 for a distance of 300 kilometer and and for a distance of 300 kilometer. This is the type first question, right? Type first question. So they will have the speeds of 20 kilometer and 30 kilometer per hour. So at what distance from A they will meet? So we know that S1 upon S2 is equals to D1 upon D2 because D D is directly D is equal to speed into time. Now here time is constant. They will take same time and they will start at the same time and they will take same time to get till here, right? And since the time is constant for both of them, time is same, so S1 upon S2 will be D1 upon D2, that is 20 is to, so 2 is to 3 will be the 2 is to 3 is the speed that will be equal to distance traveled. Now if we want to know about the distance traveled by first person or A, it will be equal to 2 by 5, that is 2 by 2 plus 3 into 300, right? So it will be 3 by 5 into 300 and it will be 60. So A will be covering 120 kilometer and B will be covering 180 kilometer. So that is all there is in this question. Now let's come to the time taken. Let's come to the time taken. How much time would they take? Now you will see that 300 kilometer is the distance, okay, and speed is what we have to take their relative speed because they both are completing this distance, right? So we will be taking 20 plus 30, okay, 300 plus 50, 5, 6, okay, this is 6 hours, right? This is 6 hours. So 6 hours will be the time taken to cover the whole distance by both of them, or time taken to meet, right? Time taken to meet. There are two types of questions here, two types of questions encountered here. These questions would be, let's move to the next page, right? Let's move to the next page. So these questions will be, suppose there is two terminals, this is M, this is N, A starts from here and B starts from here, right? So A will be going to this direction and B will be going to this direction, right? And so after this distance, what would be, if we take, let's make a general formula. They meet here, right? They meet here. So what will they be doing? What will they be doing? Okay, so this is here, right? This is here. So what will they be doing? They will take from here to here t time, right? They take the same time because they start from the same time. So this will be taken as t time, right? Now, if we see here, this this distance can be taken as, let's say B takes t1 time and B takes t2 time and A takes t1 time to cover the rest of the distance. So this distance can be written as B into t2, and this distance can be written as, let me take another pen. This distance can be written as A multiplied by t1. Now the time taken t in the first case will be given as B upon t2. This was the distance upon A. So this will be the time taken by A, that will be equal to t. Now this distance was A into t1, that is speed of A into t1. This was speed of B into t2. Speed of A into time taken by A is t1, right? We had taken that A moved from here to here, and from here to here A took t1. So we will divide this by B and we will get what? Time taken by t, right? So if we see this equation, we will get V by A is equals to t by t2. And if we see this equation from here, we will get t by t1, right? We can say that t by t2 is equals to t1 by t. So we had used a formula as such that t is equals to root t1 plus t2, because t square will be equals to t1 plus t2, t1 into t2, sorry, multiplied is there. Now let's do a question on this. Let's do a question on this concept. Okay, let's do a question on this concept. Now what we will be doing is that, let's take an example question. Let's take an example question from here to here. They move, right? And M and N will be the terminals. M and N will be the terminals, and A and B are moving with a speed of 12. Okay, A takes A takes A takes 16 hours to cover the distance after meeting. Okay, A takes 16 hours to cover the remaining distance after meeting distance after meeting, and B takes 9 hours to cover the remaining distance after meeting. So how will we find? I have given you the formula, right? T is equals to time taken in meeting, right? Time taken in meeting is equals to 9 into 16. So what will it be? 3 into 4 is equals to 12. So A would take 12 hours from here to here, and B was taking 9 hours from here to here, and B would take 12 hours from here to here. So we can also find total time here, right? We can also find total time here. So this has been covered. Now there is another formula. There is another formula, and we will have a look at that. So let's make the diagram again. This was the diagram, right? This was the track, and there was a terminal M and N, and this is the meeting point. So M and N were the terminal. A was coming from here and B was coming from here. This distance was what? T1 was time taken. This distance was A took T1 time. So distance into speed into time. Okay. This here B took T2 time. So this will be B into T2. Right. So this has been done here. Okay. Now what will they do? Okay. What will we do in the next time? Okay. Let's take let's take it here as B into T into T2 was there, right? So S1 upon S2 will be what? Will be along the lines A into T1, right? SA upon SB will be line A into T1 and B into T2, right? And also SA upon SB are given by A upon, oh sorry, this was dA. dA by dB will be given by B into T1, and this will be given by dA by dB will be given by A upon B, right? So, so how would we do it? How would we do it? We can write that, dA by dB as, okay, we have taken SA is equal to A and SB is equals to B. So we can say that here it is dA is equals to A and dB is equals to B. Okay. Okay. Hmm. B into T2. Hmm. Hmm. So let's take this new question. Okay, we will make a track here. We will make a track here. Right, so this is our track. This is our track. So we will go from A will be going from here and B will be going from here. And these are terminal M and terminal N. Right. and the terminal M and N. So what will be the concept? It is the meeting point, and this was the distance A into T1, and this was the distance B into T2, right? Because T2 was the time taken by B to come from here to here, and T1 was the time taken by B to come from here and here. So what will be the distance, right? Distance covered by, in the first case distance covered by A upon distance covered by B was given by A upon B, right? And in the second case, distance covered by B can be given as A into T1, right? And distance covered by A can be given by B into T2, right? So distance covered is A by B, so we can write it here, right? Putting in the second equation A by B, right? dA was A and dB was B. So this can be written as A by B into T1 by T2, right? So T1 by T2 would be equal to B upon A whole square. So T1 upon T2 root will be equals to B upon A. So T1 is the time taken by A and T2 is the time taken by B. So T1, A and B. So this is what is known as inverse root proportionality. So B is inversely proportional to 1 upon root TV and A is inversely proportional to 1 upon root TA. So this needs to be remembered. So let's take a question here. How would we do this? This is the diagram, and vectorial representation needs to be made. A starts from here and B starts from here. They meet here. A takes T1 time, that is A takes 32 hours, okay, and B takes 18 hours after the meeting point. So B takes 18 hours and find the ratio of their speeds. So ratio of their speeds will be A by B is equals to root TB by TA. So TB was what? TB was this 18 hours and TA was what? 32 hours. So this will be the root. We will cut it out. This will cancel out, right? And 3 by 4 will be the required ratio. So hope this is clear till now. I will be putting out some questions today on these formulas, right? On these formulas. So fine. Have a nice day.